Hello students, myself Hardik Patel from LJ Institute of Engineering and Technology. In today's session, we are going to learn the mean value theorems. Now, first mean value theorem we have to learn is the Rolle's theorem. Now, what is the statement? Let f be a function that satisfies the following three hypotheses or conditions. Hypothesis, that means conditions. First one, f is continuous on closed interval AB, f is differentiable on open interval AB, and the value of fa and fb are same. Then there exists a number c in open interval AB such that f dash c is equal to 0. Now, if you are going to check out the geometrical interpretation, then you have such type of curve. This point is A, this point is B, and this is continuous curve. It is differentiable as you can find out the derivative tangent at any point, and this value fa and fb are same. Then in between these two you have one point where f dash c is 0. That means you have a tangent where the slope of a tangent is 0. That means you have a tangent parallel to x-axis. This is the geometrical interpretation of Rolle's theorem. Okay. Verify Rolle's theorem for function fx is equal to e raised to x into sin x on a closed interval 0 to pi. Now here you have fx is equal to e raised to minus x into sin x. A is 0, b is pi. So f of a, that is f of 0, has a value 0 because sin 0 is 0, and f of b, that is nothing but e raised to minus pi into sin 0, sin pi, but sin pi has a value 0. So you have f of 0 is equal to f of pi. Secondly, e raised to minus x is continuous everywhere, sin is continuous everywhere, and both are differentiable, and therefore fx is continuous on closed interval 0 to pi. First condition. Second, fx is differentiable on open interval 0 to pi. And the third condition, f of 0 is equal to f of pi. So Rolle's theorem is satisfied. Now Rolle's theorem is satisfied, that means we have f dash c is equal to 0. And therefore by Rolle's theorem, Rolle's theorem is satisfied. Therefore f dash c is equal to 0. Correct? And f dash c, so the derivative of f is nothing but here we are going to write down the f dash x. So e raised to minus x is the derivative minus e raised to minus x sin x as it is, plus e raised to minus x as it is, derivative of sin is cos. And that will give you minus e raised to minus c into sin c plus e raised to minus c into cos c is equal to 0. Now e raised to minus c is, we are going to take this opposite side. So you have e raised to minus c sin c is equal to e raised to minus c cos c. But e raised to minus c is not 0, so this will be cancelled out, and that will give you tan c is equal to 1. So c is equal to pi by 4. Correct? And that means your Rolle's theorem is verified. Verification, that means we required one point C for which your function's derivative is going to be a 0. Now, it is given that the Rolle's theorem holds good for function this. at a point x is equal to 4 by 3. Then find the values of a and b. That means your function is satisfying Rolle's theorem. So it is continuous as well as it is differentiable, and at a point 4 by 3 we have the tangent is parallel to x axis. So fx is given, f dash x is going to be a 3x square plus 2ax plus b. Now, since Rolle's theorem is verified, so since Rolle's theorem is verified, or we are going to write it, it holds, and Rolle's theorem holds, and that implies we have f1 is equal to f2, correct? So here we are going to put 1, that will give 1 plus a plus b is equal to f2, 2 cube is 8 plus 4a plus 2b, and we are going to simplify this term, that will give you 4a minus a, that is 3a, 2b minus b, that is b, and going to write down this 8 in opposite side, so 1 minus 8 is minus 7. This one is your first equation. And f dash of 4 by 3 is equal to 0, because at a point 4 by 3 it holds. So in a f dash we are going to put the value 4 by 3. So 3 into 4 by 3 whole square, that is 16 by 9, plus 2 into 4 by 3, that is 8 by 3 x, 8 by 3 a plus b is equal to 0, and that will give you, multiply the equation by 3, that will give you 16 plus 8a plus 3b is equal to 0. So 8a plus 3b is equal to minus 16. This is equation number 2. Now we are going to solve these two equations. So multiplying equation 1 by 3, that will give you 9a plus 3b is equal to minus 21. And second equation as it is, 8a plus 3b is equal to minus 16. Minus minus plus. So these two will be cancelled out, and you will get a is equal to minus 5. A is minus 5, so put it in either of them. So here I am going to put a is equal to minus 5. So put in equation 1, putting values in equation 1, and that will give you minus 15 plus b is equal to minus 7. So b is equal to 8. So a has a value minus 5 and b has a value 8. Okay. Same manner, second mean value theorem is a Lagrange mean value theorem. In Lagrange mean value theorem, we have a two condition. Let f be a satisfying following two hypotheses. First one, f is continuous on a closed interval ab, and second one, f is differentiable on open interval ab. Then there exists one number c in open interval ab such that f dash c is same as fb minus fa upon b minus a. Now, if you are going to check out the geometrically, then this point is suppose your point A, this point is suppose your point B. So, if you are going to join this two points A FA and B FB, then we have one line parallel to this line. So, the slope of these two lines are going to be the same. Okay. Now, verify Lagrange mean value theorem for the function fx is equal to under root x square minus 1 on in the interval 1 to 4. Now, if we are starting with the solution, so fx is root x square minus 1 x. So, here fx is continuous function on closed interval 1 to 4. and is differentiable on open interval and 1 to 4, because the root of polynomial is always continuous. Done? Now, the first thing you have to find out f dash c, and therefore f dash c is equal to fb minus fa, that means f4 minus f1 upon b minus a, that means 4 minus 1. Now put the value f4, if you are going to put 4, then 4 is a 16 minus 4, so root 12 minus 1 minus 1 is 0 upon 3. So root 12, that is 2 root 3 by 3. Correct? So this one is the f dash c. That means if you are going to find the values of c, so what is the derivative of f dash x? Root as a derivative 1 upon 2 root x square minus x into derivative of x square minus x, that is 2x minus 1, and that will give you, if you are going to multiply or put the value, then you will have 2c minus 1 upon 2 under root of c square minus c is equal to 2 root 3 by 3. Now squaring both sides, that will give you 4c square minus 4c plus 1 upon 4 into c square minus c is equal to, if you are going to square this, then this will be a 12 upon 9. Cross multiply, and that will give you 36c square minus 36 plus 9 is equal to 12, 4 is a 48c square minus 48c. So we are going to write all the terms in this side. So 48 minus 36, that is a 12c square. Okay, here 36c. So minus 48 plus that will be a minus 12 minus 9 is equal to 0. Now we have to find the factors. So 12, 9 is a 108, and we have to find the subtraction such whose subtraction is 12. So the factorization is 36 into 3 and 6 into 18. So we are going to 12c square minus 18c plus 6c minus 9 is equal to 0. So from first to 6c will be common out, and you will get 2c minus 3. Here 3 will be common out, and we have 2c minus 3 is equal to 0. So 6c plus 3 into 2c minus 3 is equal to 0. So here you have c is equal to minus 1 by 2, and here we have c is equal to 3 by 2. Now minus 1 by 2 is not belonging to our interval, so c is equal to 3 by 2 is our answer, and this one is the answer. That means Lagrange theorem is verified. Okay. Okay. So same manner, find the value of c using Lagrange mean value theorem if fx is equal to this. So if you are starting with the solution, so fx is equal to x square minus 3x minus 1. So f of minus 11 by 7, that will have a value 303 upon 49. Same manner, f of 13 by 7, it has a value minus 153 upon 49. And f dash of x has a value 2x minus 3. Okay. These values I have calculated, so I am going to write it directly. Now, by Lagrange theorem, what we will have is, by Lagrange theorem, you will have f dash of c is equal to f dash of c, sorry, c is equal to FB, that is 13 by 7, minus FA, 11 by 7, divided by 13 by 7 minus plus 11 by 7. And that will give you 13 by 7 is minus 153 by 49, minus 303 by 49, divided by 24 by 7. Correct? And that will give you f dash is 2c minus 3. This is going to be a minus 4, 5, 6 upon 49 into 7 upon 24. So 7 is a 24. And if you are going to check this, then 3, 8, 24, 1 is a 24, and you will get 24. That means we get 21, 216, so 9. Okay, so we have minus 19 by 7, and that will give you 2c is equal to minus 19 by 7 plus 3. That means minus 9 plus 21 by 7. So 2 by 7, and therefore we have C is equal to 1 by 7. And this is in our interval minus 11 by 7 to 13 by 7. So this is the required solution. The last theorem is the Cauchy's mean value theorem. Here instead of one function we have a two function fx and gx, which are continuous on open interval, closed interval, differentiable on open interval, and if f g dash x is not equal to 0 for all x in interval a to b, then f dash c upon g dash c will be fb minus fa upon gb minus ca. Okay, so instead of instead of one function, now we have a two functions. Done. So first verify Cauchy's mean value theorem for fx is equal to and gx is equal to. Now see, if you are starting with a solution, so fx is sin x, and therefore f dash x is cos x. Same manner, g of x is cos x, therefore f dash x is minus sin x, and sin and cos both are, so fx and gx are continuous on close interval 0 to pi and differentiable on open interval 0 to pi, and that implies we also g dash x is not equal to 0 in open interval 0 to pi by 2. Sorry, we are going with a pi by 2 because interval is pi by 2. My mistake. Okay. So sin 0 has a value 0 and sin pi by 2 has a value 1, but 0 is not included here. So it is not 0. And therefore, by Cauchy's theorem, what we have, if you have to find f dash c upon g dash c is equal to f pi by 2 minus f0 upon g pi by 2 minus g0. But f dash c is cos c, g dash c is minus sin c is equal to f pi by 2 sin pi by 2 has a value 1 minus sin 0 has a value 0 divided by cos pi by 2 has a value 0 and cos 0 has a value 1, and that will give you minus cot c is equal to minus 1, and that will give you cot c is equal to 1, and that will give you c is equal to pi by 4. And that means we have values pi by 4 which is in our interval. Therefore, Cauchy's mean value theorem is verified. So these are the topics for the mean value theorem. If you have any doubt or any queries regarding these topics, then please feel free to contact me. Thank you so much for watching.